Learning rate is one of the most common hyperparameters that we talk about when we are referring to machine learning and AI model training. Now, it's one of the most common hyperparameters that we talk about because it's so easy to update. It's a simple number, right? It's a floating point number that we can increase or decrease. So it's really straightforward, but you're figuring out what that value should be is actually challenging. It's pretty difficult because it has a significant impact on the training time of the model, but also the model's outcome, right? Being able to actually provide a good model at the end. Due to having a too low of a value, you're not going to be able to train fast enough and you're just going to waste compute. But if the model is too high, then you can actually, the model will fail and it'll explode depending on what your model is set up to do. And so you always want to make sure to assess the impact of the learning rate for the process of the training time, right? Because that's going to take a while, but also the resulting model and its performance. And the performance in this case means how good it is, right? The accuracy on data that it's never seen, and even data that has seen in proximity. How good is it, right? You want to know what the optimal selection practices and techniques are. So you want to study those because that one value, it's really meaningful. It's super powerful and you can make adjustments. It's actually really straightforward. It's really related to here in the mathematical representation. So we've got the learning rate, you've got the weights, which is the model's parameters, right? The number of units, the parameters in the model, right? So this is a matrix right here. And then you've got the learning rate, which is a floating point number. It's less than 1. And then your gradient, which is the loss, which is the delta of how wrong the model is when it makes its prediction. You apply the learning rate to the delta and then ever so slightly adjust the model weights over and over and over again until the model finally learns the patterns. And that is what the learning rate is. The learning rate hyperparameter is a critical attribute when you are talking about machine learning and the training cycle, and it's only used during training, right? And so what you want to do is, what is the learning rate? That's the question. How high or how low do you set it? During training, the convergence speed is going to be highly influenced by the learning rate. If you have a high learning rate, your speeds, so here's essentially the idea of a high learning rate. So the speed up of the convergence, which means that you need to train less. Over time, it'll be you'll be able to train your model a lot more quickly if you have a high learning rate. But if you set it too high, you have a risk of overshooting optimal points, which can't converge as well. You'll have a lower performing model. And so if you set it really, really high, it's going to cause a lot of jumps, but it can't get in between those jumps to get a more accurate representation of the total data that you have in it. And if you set the learning rate low, there's actually some good benefits here, more precision on convergence, and then you'll have smaller steps to finding a minima if you make it that far, right? So the con here in this case, of course, it's going to take a lot longer to train. And so it is good overall. We see that in the industry, we do see a lower, we tend to go on the lower spectrum for learning rate. So here's a quick tip for you with the learning rate. If you set it at a high level or a low level, you're going to have a variety of outcomes during the training cycle. And the idea behind it is if you set it too high, you can have what's expected as these oscillation periods. So see, if we set the learning rate too high, it can cause the model to diverge or oscillate around the minima. So the ideal point could be right here, but you will be jumping around. You might not be able to approach that, the actual truth, the point where it needs to be. If your learning rate's too high, it can never reach that point. But if you set it too low, then it can get stuck in a local minima where the ideal point is here, but they will actually result in sticking right here, and it can't escape. It can't escape to a lower point where it's going to be able to get a better result with the model overall. So you want to be able to set the learning rate high enough so that way it can get into the right spot. But if you set it too low, it's also possible that it gets stuck. That's a problem. If you don't know what to set your learning rate to, I've good news. You don't have to so much. One of the industry standards for today is to use a learning rate adapter or dynamic learning rate. There's multiple approaches with this, and you can have constant learning rate, which is what we might be used to from the beginning, where you just set one fixed value and it never changes. But the good news is there's other approaches that have a dynamic scheduler, so with adaptive approaches that allow you to decay the learning rate over time, because you want to converge right towards that global minima as soon as possible, so you can have a high learning rate at the very beginning, and then you can slowly tape down the learning rate so it gets smaller and smaller and smaller, and then you can train just a little bit longer, so that way you can capture more of the details of the training data you're sending it. You can do exponential decay as well. There are also adaptive optimizers like RMSprop that will tune based on its understanding and what it finds is ideal in its ability to make adjustments to the learning rate over time, right? Because it's essentially additional parameters that will go into affecting the learning rate overall. You'll still have a base learning rate, but those optimizers will adjust the learning rate in a variety of ways. So after your model has already finished training, we will take a look at the output of the final model based on the learning rate that you gave it. So for example, the training accuracy, the performance of the model, how good is the model overall, we will see that based on a high learning rate. It's easy to achieve an initial accuracy sooner, right, with fewer epochs. You will plateau sooner as well, because you can't if you can't get to more accuracy when the learning rate is too high, because you're going to jump around all the different points of more precision with the data that you're showing it. The good news with a lower learning rate, you're going to see slower, it's going to take longer to get there, but you will be able to achieve higher peak accuracy overall, which is fantastic. And if you take time to do it, you can find a properly tuned learning rate with a variety of approaches. Either you can test a couple of runs and see which ones tend to work better with the data set that you've got trained it on, or you can use some common practices and algorithms on the first epoch to find a generally good way, a good number that you could use that's a static number. The whole idea of machine learning in general is generalization. The idea that a model can find common patterns with all the data that it sees and provide an output that's predictive and has a high accuracy. That's the whole point of what AI is. We can do that. It can find all those details for us. And the hyperparameter of a learning rate will have a significant impact on the success and the performance of the model. For example, generalization, you have a problem with overfitting versus underfitting, and the learning rate has a huge impact on if you hit one. Both of these are bad problems. You don't want to overfit or underfit. You want it just right? Because you want to be able to get as much data in generalization as possible. The idea with the AI is it can give you a highly accurate output based on data it's never seen before. So that way it's really intelligent and it can make conclusions based on past data that it's seen. So with a high learning rate during the training process, you have a risk of underfitting due to insufficient learning, right? If your learning rate's too high, you're going to jump around, the ground truth for all the training sets that it sees, and you're not going to be able to converge on a more accurate number. Lower learning rate has a risk of overfitting, so that way all the training data set that you show it, the model will be able to learn that training data set really well. But if you show it new data that it's never seen before, it's not going to get it accurate. It'll have a lower chance of accuracy. This is why you want to tune your learning rate. If you weren't sure what to set your learning rate to when you're training your machine learning model, good news! There are several industry standard techniques that we can use to take advantage of having an easy way to select your learning rate. Now, this is one of the tried and true ways. Obviously, it's going to be the way that I've done it this is the way I like to do it, but there are other ways as well. This is the easiest one, where you just do a range test, where you just do a few cycles, a few epochs, choosing a few learning rates, and then taking a look at the outcomes at the end, finding the highest stable learning rate by starting at the beginning and then gradually increasing the learning rate during a single epoch will give you the ability to see, at what point should you set that learning rate to. It's a common best practice. Just give it a try and see which one works. There's industry standards when it comes to selecting our learning rate. The good news is we have some common practices with schedulers and adaptive methods that make it a lot easier, so you don't have to pick a static learning rate number. You can have the algorithms do it for you. Check this out. There's common schedulers, which is pretty easy these days. You've got step decay, exponential decay, and the one cycle. The idea with step decay is you start with a high learning rate and then you just start ratcheting it down. You want to do that because you want to be able to capture as much of the details up front, because the initial few epochs is going to be able to get closer towards the actual, the end model rather than having a low learning rate that's going to just take a lot more epochs to get there. So it's better to start with a high learning rate and then decay over time. These are two similar methods, and the one cycle will also add in an extra bit where it throws away a few of the training cycles in order to find the highest possible learning rate and the lowest possible learning rate, and it uses those as ranges. Then we also have adaptive optimizers that can be used in tandem with the Atom Optimizer, RMSprop, and Adigrad. These are models that add additional parameters next to the learning rate, which will make adjustments to more quickly converge on the global minimum as best as it can, and it will allow the model to learn as well with having a lower and lower learning rate when it nears the end of the final epochs. So if you're picking your learning rate with your machine learning model, my recommendation is just to use the industry standards and go with dynamic learning rates. If you pick a static learning rate, then you will have to figure out what an optimal rate is going to be, and it's not going to give you the best possible outcome because you'll be wasting a lot of compute, or you will not have a good model as the outcome. For example, if you set a high static learning rate, you will have your outcomes will lower model performance on the outcome, but you will be able to train a lot more quickly. So it might be good to have a high learning rate if you're just testing the model initially, right? So that's actually a pretty good reason to use a high learning rate that's static. You want to use a low learning rate. If you set it too low, it's going to take a lot longer. The good news is you're going to have a really good model at the end, so it's possible that a low learning rate could do good for you in that case. Really though, it's better to have optimal learning rates by having dynamic adaptations. And so what you want to do is use step decay, exponential decay, and the optimizers as well, which will make adjustments to the learning rate.